In the next few videos, we're going to be looking at exponent rules, or rules for manipulating expressions that have exponents. In this video, we're going to start with positive integer exponents, and then in the next we'll look at zero and negative integer exponents, and then finally rational exponents. So let's start with positive integer exponents. The first thing to remember when dealing with exponents is that they tell you how many copies of the base to multiply together. Remember, this bottom part, the 5 in this case, is called the base, whereas the 3 is the exponent. And 5 to the power of 3 means multiply 3 5s together. In other words, 5 times 5 times 5, which is 125. It's a simple point, but it's one that will help us understand why the exponent rules are true. Let's look at the first rule, the exponent product rule. When you're multiplying two or more expressions together that have the same base and have exponents, we can use this rule to simplify. So first, let's think about what 3 to the power of 2 and 3 to the power of 4 is telling us. 3 to the power of 2 is telling us to multiply two 3's together, while 3 to the power of 4 is telling us to multiply 4 3's together. Altogether, that means that we'll have 6 3's. And remember, the way of expressing that with an exponent is 3 to the power of 6. So 3 to the power of 2 times 3 to the power of 4 is 3 to the power of 6. We could use a shortcut for that next time because we recognize that what we've done is add the exponents together. So when we have like bases, we can multiply them together by adding the exponents. In this case, 3 to the power of 2 times 3 to the power of 4 is equal to 3 to the power of 2 plus 4, which is equal to 3 to the power of 6. So the general rule is when you have like bases, you can multiply them by adding the exponents. Similarly, there's a quotient rule for exponents when you're dividing two powers with the same base. In this case, x to the power of 5 divided by x to the power of 2 means take 5x's all multiplied together and then divide them by 2x's multiplied together. We know that that's going to allow us to cancel out 2 of the x's, giving us x to the power of 3, or 3x's all multiplied together. And again, we can use a shortcut because now we recognize that what we're doing is subtracting the bottom exponent from the top exponent, or x to the power of 5 minus 2 is x to the power of 3. So the quotient rule for exponents is when you have two expressions with the same base dividing each other, you subtract the bottom exponent from the top exponent. There's also an exponent power rule. When you raise a power to a power, in this case, 2 to the power of 3 squared means take 3 2's multiplied together and square that. That in turn means take 3 2's multiplied together and multiply them by another 3 2's multiplied together, which would give us 6 2's all multiplied together, or 2 to the power of 6. What we've done in this case is we've multiplied the two exponents together. So 2 to the power of 3 squared is equal to 2 to the power of 3 times 2, which is 2 to the power of 6. So the exponent power rule is when you raise a power to a power, you multiply the exponents. This is also true when you've got multiple parts to a term. So 4x cubed y squared is equal to 4 squared times x cubed squared. We multiply the exponents together, and y squared, which is going to give us 16x to the power of 6 y squared. Similarly, 3/4 squared is the same as 3 squared over 4 squared. You can bring the exponent in like that, which is equal to 9 over 16. The reason you can do that is that 3/4 squared is the same as 3/4 times 3/4, which is 3 squared over 4 squared. You can include that step in here if you want to, but you don't have to. So those are exponent rules for positive integer exponents.